Hey there, this is your second example of exponential applications. It has to do with the car value that is depreciating, that is losing 20% of its value every single year. Okay, so to determine the value of the car after X years, we need to complete the table. Remember that it started off with 100% of the value, and then minus that 20%. So every year it is only worth 80% of the value that it was the year before. So also you need to keep in mind that we need to write that as a decimal. So we're going to take 20,000 and multiply it by 0.8, and then you get 16,000. That's kind of scary to think about. Just 1 year later, your car is decreased by $4,000. Then we're going to take that 16,000, multiply it by 0.8, just like we did in the previous problem, and you get 12,000, and 800. We're going to take that value, multiply it by 0.8, and you get 10,240. Multiply that value by 0.8, and we get 8,192. And multiply 8,192 by 0.8, and we get 6,553.60. Multiply that by 0.8, and we are going to come up with 5,242.88. Okay, so if we start that graph, it starts up here at 20,000. After 1, let's see, this is 10. It's going up by 2s. So 2, 4, 6. 2, somewhere about right here. And we're close to 10,000 on this one. And 8,000, a little more than that. And then a little more than 6. So somewhere about right there. And 6 is right there, about 5. Somewhere up there. And this graph will look something like so. Okay, you think about your A value. It's equal to 20,000. So your function is going to be 20,000 times. And if we divide it back, if we find the ratio, it's going to be the same thing that we multiply throughout everything. So it's going to be 0.8 to the x power. Okay? So how much will the car be worth after 10 years? Well, whenever you're doing that, we're just going to do that 20,000, use that function that we just found. Except we are going to put in 10. And 20,000 times 0.8 to the 10 power is equal to, let's see, 10 years is going to give us $2,147.48. Okay? In 25 years, you're just going to replace the exponent with 25 instead of 10. And you get $75.56. Okay? According to this function, when will the car be worth? That must be a typo right there. When will the car be worth absolutely nothing? Well, no matter what exponent you put in here, for example, if I were to put in 100, it still has a very small amount of value. The reason being is because that horizontal asymptote is going along with 0, or y equals 0. So theoretically, never. Okay. What is the domain and range of the problem situation? Well, we know that our domain is starting at 0, and it goes on forever in the positive direction. So x can be greater than or equal to 0. And the range, however, is slightly different because the smallest value that it will approach is 0, but it's never going to equal 0. So we only put greater than. Y is greater than 0, and then, but it's always going to be less than 20,000. But at some point in time, whenever they first bought it, it was worth exactly 20,000. So this is my last example of an exponent application. I hope everything was clear in that. If you have any questions, be sure to write those down and be prepared to talk about those in class. All right, thank you. Have a great day.